Good. Hopefully, if we start on time, should be 20 minutes. Much, at the most, like 30 minutes. But I don't think it's gonna be 30 minutes. 20 minutes, optimistically. 30 minutes, like if I start talking too much. But I will really try to avoid that. I think that 20 minutes should be. Yeah, yeah, definitely. I have like my watch actually. Check it.
It says you're joining a Bible study tomorrow.
Tomorrow?
The Go study group.
Yes, Ferdinand told me about Golan.
Yeah.
I want to do that seriously. And Melboy is coming to. When is it? Is he coming? Yeah.
Sometime. I heard he's doing a thing.
Okay.
I don't know when. She mentioned something about that.
Um, I think it would be pretty cool.
Richard's also interested in doing stuff cross company.
I think it's a great idea.
That'll be cool. It's nice for language.
I'm quite excited like to learn, and I've been trying, but kind of always like got involved in something. Oh, no, at the end, I never actually tried. So
You want to drink today?
When you look at the video,
Played around with it like months and months ago.
like it's about
The thing is, like, you learn the basic syntax and you do something and then you never touch it again. So it's nice to have
yeah, to go back and
correct.
because if that's the thing, if you don't really use the language at the end, you end up kind of leaving aside, putting time, your own time. So.
But then we can't see Eduardo.
Well, you don't need to see me actually. You don't-
What was this?
Is this thing working? It's working.
Amazing. You can't even check that. No, I can't. But if we put it there, we'll probably even check it.
It's a bit better when you look at the images darker. Okay, might as well put the
I'm gonna feel jealous about your food. It looks like very well prepared.
slide that's reflecting off the screen.
Then you can share the slide as well. I thought you bring in your friend.
Yeah, he didn't come.
Welcome everyone. So today we have Eduardo doing his introduction to Earth observation application. So during the talk, he will be giving out some spot prize for people answering or asking questions. And if you are willing to do a brown bag, please come talk to me, Ashik, Karen, and Jordan. And let's get this started.
Thanks for the clapping. I didn't start and you're already clapping. Well, so Earth observation. Has anyone done anything about satellite image processing? Cool. So then you are in the right place, I guess. Well, the idea, basically, I had this idea of doing this brown bag because I, in the past, worked in this field. And I think it's a really cool field. People actually don't really know about it. And actually, we can end up as a software developers here. I know everyone, we're all software developers. We can end up finding answers to some questions, or we can find solutions to some problems using some technologies that we don't use at MYOB, but I think they are like pretty useful. So in developing countries, still like deforestation is an issue. That's happening right now, and I think I read the other day, at the current rate, 40% of the Amazon will be gone by 2030 if we carry on deforesting like the rainforest. So it's a problem. And for example, it's a really big area, the Amazon, just you cannot really go everywhere. So some countries, for example, Brazil, is already using satellite image processing to detect which areas are being deforested. So it's a really clear example about how like satellite image processing can help to solve some problems and fight actually like against some issues that happen. What is this? There are some Europeans here. Can someone guess what is this image?
Snow?
Bingo. So why some countries want to know maybe what's the snow coverage? This is an image, and here we are seeing just the snow coverage in basically Europe. Pretty much we can see most of the snow is in the Alps, some at the north of Spain. And we have a problem like it's pretty popular, I think. There is like water shortages in many countries. Right? And at the very end, the snow that we have in the mountains is the water that we end up having in the taps. So some countries at the end like need to know how much water do we have up there in the mountains, right? And using like satellite imagery, we can actually detect how much snow we have in the mountains, and eventually we will have in our taps. I think that, for example, I was reading the other day about South Africa, and I think that it's a pretty interesting like case. But you don't have like much snow there, by the way. So these are a couple of examples about solutions or how we can use satellite imagery to try to solve some problems, right? How does it look at satellite image? Like in general, we are used to like normal images. They are just a bunch of like colors put together. They look nice, but satellite image probably doesn't really look like that. It looks more like this and doesn't look that sexy, right? Compared to what we were seeing before. It's just a matrix, right? Just with pixels, and each pixel basically has a value, right? It's just a number. So this image is about chlorophyll concentration, which is another like product that some satellites provide for us to use, okay? So this matrix is only an image of 9 by 9, I think. And we have, for example, an example of in one pixel, we have like a value, and related to that pixel, we have a latitude and a longitude. So at the very end, like there is a mapping between like certain like measurements and a position, a geographical position. That's where actually like we see the difference with normal images, where we talk about colors, but here we are just talking about values related to a geographical position. So why, for example, like the chlorophyll concentration is useful? It's another product. Some satellite image providers like give these images. And the interesting fact about this thing is that chlorophyll concentration is just detecting phytoplankton in the water. The more phytoplankton there is in the water, the more fish and more like marine productivity there is in that area. So for example, as humans, like at the end, we need to know if there are drops in chlorophyll concentration in phytoplankton in the water. At the end, eventually, maybe later on, we don't really fish a lot of fish. We maybe have even less food. So there is an implication about seeing this and seeing this. At the end, this is the same as the previous image. This is just the chlorophyll concentration in the waters of New Zealand, but just we are giving colors to the values that are associated in that satellite image. So a very easy thing to do is just, okay, we have an image, a satellite image that contains values. Just if we give colors to those values, we can actually, humans, understand what is in that image, right? So for example, we can see in the South Island, there are like higher like concentrations of phytoplankton per cubic meter. Okay.
Australia is stealing all of our photos.
Seems like that, yeah. Near Australia, seems there isn't anything. Any questions so far? I'll be happy like to answer questions along we go, rather than me just talking and making you feel sleepy.
Is there any difference between the images provided by different satellites? So like the different satellites, is there like a standard, or they just randomly having different cameras and it's up to you to figure out the...
It's quite complex. It depends, because at the end, a satellite is a bunch of instruments, and sometimes you find different satellites using the same instrument, and in general, they will generate a very similar image, because the instrument, the sensor is very similar. But in general, like satellites like run by NASA are quite different to the ones run by the European Space Agency, for example. It's very interesting. Later on, we will talk about processing images. How does it work? And in general, each case is quite particular, and you will process images depending on what you are trying to accomplish. And they actually like the data source, which is a satellite.
So are these just available publicly?
Yeah, we will go with this in 2-3 slides how we can use actually these data sets. Cool. Well, so this is like the chlorophyll concentration stolen by Australia. I hope no one gets mad. Something interesting. Well, we saw before here. Okay, images are just a bunch of values and a related latitude and longitude, but it's more complex than that. At the very end, like a satellite doesn't actually provide the image we saw before. They just generate like some product. It's an image, and there are different processing levels, and that's what I try to explain in this slide. Basically, satellites generate images that are in level 0, which means it's just an image with some values, but it's just in a very low level. Like there are like lots of like errors. There isn't any calibration. So it's a very raw data, just data coming from the satellite by itself. For us, it's really, really hard to use this unless you are like a supreme satellite image processing ninja and you know what you're doing. I'll never get there. Like it's really hard. Later on, we have like these images, raw data. We can actually later on do some corrections, and that's the level 1. Then later on in level 2, you take that image that has been like corrected. Then you add geographical information. So you relate pixels to geographical locations. Actually, the example I was showing before could be an example of an image that could be level 2. Just an image where its pixel is related to a geographical position, and we have the value still. And level 3 in general is composing like multiple of those images. In general, satellite images are very small. It might be only like this small area, right? But if you really want to have a bigger picture, you need to compose together many of those images, right? And that's when we talk about level 3 images. Okay, lots of talking. I wanted to do a demo. I've been talking for 10 minutes. Let's go with that. Let's gonna try to do a case study, okay, which is the study of the sea surface temperature for the Pacific Ocean, okay? But we won't see like only the sea surface temperature, we will see the anomalies. Basically, anomalies is just in average between 2003 and 2018. In the month of January, there is an average temperature in the sea, in the Pacific Ocean. Then we will try to generate images and try to compare this base image of the average of during the whole 15 years with each month of January. And we will see if there are differences in the temperature in the sea. Okay? This is an example of a data provider. And you ask this question, is like, how do we access this information? This is one of the pages. This page is Ocean Color. It's a service provided by NASA. These guys run a satellite, send the information back to the Earth, and they publish this information here for us to use. Interestingly, that's why I introduced the concept of levels. Here, it's a screenshot of how to download level 3 images. If you start looking in the page, you can download like level 1 and level 2 images. For that, probably to use those images, probably you need like more knowledge about it. Cool. So imagine we go here, we download the image for each month of January from 2003, 2004 until 2008 and 18. And then we download a whole image that gives us the average of temperatures in January. Okay. So, and then we try to get the anomalies. So this is what actually we will do, right? Like this is the image that contains the average temperature, and actually it has some colors already. Like we already applied a color map. This is basically the sea surface temperature for 2014, January 2014. That's the average, okay? And basically the result, if we subtract the values between both images, because just remember at the very end in each pixel we have different values, right? So we can just make the difference and get the sea surface temperature anomaly. Is it confusing my explanation? I can go again. No? So we can see basically in this area, I think it's very small, maybe you don't see. In January it's very cold up in Japan, Korea. In this area, the average temperature is around 6 degrees, but in 2014, the temperature in this area was 9 degrees, which is almost 4 degrees higher. That's why we get these warm colors, and that's what it explains. Okay, so this is basically an example of we want to get this information, and we will do this operation, just doing the difference between images, which sounds strange in normal images, but in satellite images is a very simple example. So I wanted to do this processing on live, but I don't think you have 2 hours of your time. Okay, so this is how it looks like. The processing, I tried to do it to automate it. I didn't automate the full pipeline, so at the end I just basically did some parts of it like manually with a tool. In reality, then this is the part that is more manual. There are tools basically that let you compose different images, and you end up having the final product. Okay. I'm very productive. Yeah, I think this is is probably 15 minutes, I think, of work put in 20 seconds. And in general, to do the whole, for all years, it took me like 2 hours, something like that. Okay, well, let's see how it looks like. We basically generate those images, and this is the result of this process. We basically download those images from the NASA website. We do the operations we saw in that video, and we end up with this image, right? That's for the sea surface temperatures anomalies for 2003. We can see for each year, it's quite different, right? It just changes. And we can see the anomalies for each year. There is something very interesting in this picture. I don't know if you notice these very red colors. That means that sea surface temperature was above the average and in a big area. Can someone tell what's going on here? Not Fukushima. That would be here. I loved it. Have you heard of El Nino effect? Yeah, the El Nino effect is basically the Pacific Ocean like getting like very, very warm in this particular area, and it's a natural process. It happens some years, and we can see that in 2016 it was like there was an Nino event. Similarly, in other years, there's a neutral year, neutrals years. This probably is La Nina, which is the opposite. It's under the average. El Nino is back again here. El Nino probably, and here again. So it's a natural phenomenon, but actually doing this processing, we can actually verify, okay, that's right. We got like El Nino events here.
Over the years that we've seen the El Nino effect on the Pacific, that rate has gotten significantly darker. Does that mean that the El Nino effect has warmed quite a lot over each time it occurred?
So El Nino happens only on particular scenarios. It basically is the effect of different pressure, atmospheric pressure in different places, and that causes the Pacific Ocean to become warm. Then when El Nino effect happens, there is a reverse in the cycle, and then the waters like become cold. That's why after a Nino event, it tends to go back to neutral, and then after a while, it goes to La Nina event, which temperatures go under. The effects of the El Nino event is basically you can have like droughts here in Australia or in the Pacific, or sometimes in America, and you can have like heavy rains as well in both sides of the Pacific, right? I'm not like a scientist. I don't know much about El Nino. That's actually pretty much what I know.
The formats of the data on the different levels, is it the same? Is it just PNGs or some specific format for the image processing?
The format is different in each level. For example, in level 3, you might have in a layer the values and the geographical position. In level 2, you have that information as well. But in level 1, you don't have the geographical position relative to a pixel. So to do this example, for example, to really identify which pixel belongs to which area, you need to have like the latitude and longitude. That's why we were using like level 3 images.
So this satellite image processing will have its own data formats for all the steps.
Yeah, exactly. Cool. Well, so this is an example about, well, we wanted to do like some data processing. We saw like anomalies in the Pacific. Okay. Cool. This is not moving. Ah, it's moving the slider. That's silly.
You Chrome, you're on the presentation.
All right. Hey. Thank you. That was very smart. There you go. So cool. About satellite image, I think I've been talking 20 minutes. I have like 5 more minutes and we are done. I promise. Oh, sequel. Probably no one like really expected to see this when we are talking about satellite information. So just imagine we have a table with tweets, right? And just people talking about rain, right? And you really got these very important people talking about rain, right? Like, cool. You are saying that. I'm not saying that. Thank you, by the way. But okay, let's gonna connect it to geographical information. Imagine that we just want to get tweets of people talking about rain, but just tweets that are sent like in a kilometer of distance from Auckland CBD. And well, we don't have the Twitter API. You can do that, but we just have a table here, right? Okay, well, cool. How do we do that, right? And I'm mentioning this because it's quite common when you present like geographical information. It's very common to add basic information on top of it. For example, like adding like markers or adding like some extra information, right? We'll do a small example. So imagine we want to know which tweeters, I don't know if that exists, are inside that geographic area. You have like basically a location and just you want to know which one is inside, right? So there are basically probably most of you have heard of Postgres, right? There are other like database extensions from MySQL for SQL, but for Postgres, for example, there is one called PostGIS, and basically it adds features that let you do like complex queries related to geographic information, right? So that's what I wanted to show because sometimes, well, it's something we don't really need here, but it's a pretty common scenario when you work in GIS applications. So that is how it looks. It's a SQL database, but for example, now we see, okay, I just want to get the tweets, which the distance between its location and that latitude and longitude, which is minus 36, 174, that's Auckland. The distance is smaller than 1,000. And you can end up like having like pretty complex queries. This is just an example. Asking for resources in your database, just asking like geographic information. Cool. So for example, I've got another example. This is a web map service. I didn't introduce much about it. It's just a sort of like a Google Maps that you can interact with it. Okay. There's a service behind, doesn't really matter. And I'm printing on top of this map, I'm printing a layer that shows the rainfall. Okay. And that's information for last Sunday. So it was raining in these areas in Australia. And I have a small database there with some tweets I downloaded from Twitter. And basically, every time I click in the map, I'm asking the database through the previous query, hey, give me the tweets of people talking about the rain, right? So here, that's Adelaide. This guy was saying, oh, well, this agency probably saying something about the rain. Here, of course, that was raining here. People were talking about some rain in Sydney. That's quite right. And at the very end, it's just using the same query we saw before, just a small backend doing the request to the database, right? And if you're not very happy with the demo, because this is not really a demo where I started like coding and stuff, you can always check. I'll go back again. Here, you can check the source code. Everything is there. You can just pull, try to run it. If it works, that's awesome. I haven't done it. And if it doesn't work, come talk to me. Okay. And I think that's it. I've been talking 32 minutes. That's a long time. Just one more minute. I've been working at MYOB 1 year, and tomorrow someone is leaving. Someone is finishing working here at MYOB. And I just want to say that it's been awesome to work with you, Richard. And it's been very inspiring, and I've learned a lot from you. Okay, so thanks, Richard. I think this is for you.
Thanks, Eduardo.
Yeah.
My pleasure.
Cool. Well, questions?
Are you using React?
No. In fact,
That was it.
if you see like the front end code I wrote in a rush, it will make you cry. But it's only a demo, so I have excuses.
So, by seeing the tweets in a location on a map like that, what problem were you trying to solve?
Yeah, it was just an example of using a PostGIS database and how we can actually use that SQL query to actually request information. There wasn't much of a problem there.
And this identified Twitter API, what does that return you the actual geographic
Location.
position of the tweets?
Pardon? Can you say that?
Does Twitter returns the geographic position
Yeah.
of the tweets?
Of those tweets that are geolocated, you just get the latitude.
Also, they must be tagged specifically for
Uh,
the location.
yeah, and actually you can just do a query saying, give me the tweets talking about rain. Actually, that's what I did. And within near this location, and you just provide the latitude and
I'm
longitude.
a Twitter user, just wondering
Yeah.
how much data it exposes to the
Yeah, to be honest, I downloaded only 5 tweets. Like I got a bunch and just I got like I didn't really need that many for the demo. So basically I got some in Adelaide, some in Melbourne, some in Sydney, and then I was
And then
good to
you
go.
click exactly where you got it.
Yeah, exactly. In fact, it's funny because I was trying to get tweets in this area. Oi, no, that's right. It's in Chrome. In this area, but I was never getting any because probably not many people lived in that area. So I was always getting like empty responses because it needs to be that specific day. So
You said you used to work stuff. What kind of work did you do?
So it was a company where they provided solutions for basically government agencies, the government, like the European Commission, and basically we were building products like to answer some of those questions, like not there's no coverage, but other things like see you. We were providing basically like different products, combining different data sources, and we were using satellite information like to display some information.
So what's the coolest
The-
product you put together?
I remember one. I don't know what happened because I left the company at the time we were still working on it. It was basically mixing the vegetation index. You can tell if like vegetation is healthy, and we were trying to cross it through an inventory of the trees in a city, and we were trying to detect if the trees in the city were healthy or unhealthy. You can predict in spring, you can tell that trees of this particular species like should be this green, and if you see something is not in following the usual pattern, you can probably have a tree that is dying, for example.
One example of the data sources you show is the net from NASA
Yeah.
about the ocean.
Yeah.
How frequently they update the database? Is that like online from the satellite immediately, or is like a week behind? How frequent is that?
It cannot be online from the satellite because the satellite provides L0 products, and almost any of the agencies provide L0 products. You can find L1, and I think you can find probably today in that page the results they took yesterday. If you really want like near real time, some agencies offer you amazing plans where you pay some money and you get the image like as soon as possible. And if you even have more money, I think some companies let you paying a lot of money. They will put your instruments in a satellite and they will send a satellite for you, so you have the data whenever you want. But you need.
So you showed us one, the NASA source. Is that open source? Is there other open source places?
It's not really. I don't know if it's open source. Good question. I don't have the. That's Ocean Color. I know the data is public, and you can request it, and they offer level 1, level 2, level 3. I don't think it's open source in the sense that you don't see the source code they are using to process those images.
Okay, so it's just public.
Yeah.
Do you know other sources that are public?
Yes, the European Space Agency, like for the last 5 years, have been sending like new satellites. They are called Sentinel, and if you go to Google and you search Sentinel data access, you will just find a website and you can basically download the products. Then that means that there is a lot of information, and those agencies publish like really long PDFs to help people process those images. And actually, you can end up understanding what are those images, and if you need this product, how you can process it to achieve that.
Any other questions?
Do you have a question?
Yes, actually, I have a question. I forgot actually. Well, apparently there's like how was the thing? Yeah, you can explain it. Maybe I forgot.
So he would just ask a question, and whoever answer will get a prize from Eduardo.
Yes, exactly. So I have stickers, yeah, and I forgot to give them away. The question is, that's gonna be very easy. Which country is using satellite image processing to detect deforestation? Oh wow! I think you were the first one I saw like raising the finger. Yeah, so I think it is. So is this the prize? Is this the prize?
Yeah.
Yeah. Okay. So these are. I think I forgot. I wanted to give like stickers to everyone asking questions, but I forgot. I forgot to do that.
The ones I can share with more people.
Yeah. Then you can share with everyone, pretty much. Well, that's it. Thank you. Thanks for coming.
Thanks for coming to our project, and thanks to Eduardo for the amazing presentation. And I think that's it.
We've also got Ivan doing the next drawback on JavaScript in the browser.
We'll be here.
And we